Okay, so today we're gonna just be talking about chemistry, which is the study of matter. And matter is anything that takes up space and has mass. Um, and mass is just the amount of matter that makes up an object. So, I know I'll do that pretty fast, but and I don't know if you guys are like able to talk right now, but if you could, then I just wanted you guys to think about three things around you that are made of matter.
I think they are mute.
Okay. Are you guys able to unmute and talk?
Salome. Salome? Let me see. Let me call. Salome is mute. She's not talking. She's not answering. Unmute her. Wow, they got disconnected now.
Oh, okay.
What? I think they trying to unmute, so that's what happened.
Oh, okay, okay.
Yeah, they should coming back. What? They still here, the Browns.
Oh, okay.
Oh, okay.
They left.
Yeah, I think they disconnected.
I think that what they tried to do was they were trying to unmute, so probably hit the wrong button.
Okay.
Let's give them a minute.
It works now.
Okay, great.
Okay, okay. Before I share my screen again, were you guys able to join the link that I sent last time? I don't know if you guys
Mm,
remember.
No.
Oh, okay. I sent another link in the chat. Can you guys see that?
Yeah, I see it here. Um, Salome hit the place where it's chat, so it will open up the chat room. Are you using what device are you using? An iPad, a laptop, or a phone? Salome, I don't know what happened. I think they are traveling. That's what. Then at home, that's the problem. Probably they're using.
ይኸው
Oh,
ዱላ አሁን
Um,
ማውራት ትችላለች። ይች ለብቻ
I'm sorry. It did not work, so that's why the mute thingy.
oh, it's fine. Are you guys like, is it working now?
Yes, it's
Okay.
working now.
Okay, okay. If you click if you click the chat button, can you see I sent a link.
Yeah. I can't see it.
Okay. I'll send it towards the end of the meeting since I'll just get started now with the lesson. It's okay.
Okay.
Okay. So this week we're just going to be talking about chemistry, which is the study of matter, and getting right into it. Oh no. Getting into it, matter is anything that takes up space and has mass. And if you're wondering what mass is, it's just the amount of matter that makes up an object. Now, I know we're kind of going through this a little quickly, but if you guys can just like look around your room and tell me three things that you think are made of matter. I can go back to the definition.
Salome, did you hear the question?
Yes.
So do you see
I
anything?
think I know the answer.
Okay.
Can
I
I?
think
Yeah, you guys, you guys can just answer.
Okay.
um
So I
I
think
think
matter, like three things that are made of matter is like a book, air, and water.
Yes. Yes. Because everything is made of matter. The desk, like desks and air, the air rather, your backpack, even us, we're all made of matter. And there are three, or I guess four, but we don't really talk about the last one. But there's three main states of matter. The first is a solid. Solids keep their shape. They have a fixed amount of volume, which means that the amount of space they take up is the same. And if I can just move this, they are tightly packed. Um, the second state is or are liquids, and they take the shape of their container, but they do also have a fixed volume. And lastly, we have gases, which take the shape and volume of their container, or rather, they don't have a container, and their volume is not fixed. I said a lot of things, so I'll give you guys some examples. Examples of solids would just be most of the things you see. You guys mentioned a book, that would be a solid. A brick, a rock, things like that. Liquids are an example of some liquids are water, anything that you drink, and for gases, an example of that would just be like you guys said before, the air, things like that. I went over a lot of things, so do you guys have any questions right now?
No.
Okay. The fourth state of matter is plasma, but we don't really talk much about it, but it is what is in things like lightning and stars. So, using the things that we've learned up to this point, I want you guys to just imagine that I open a bottle of perfume and I spray it, but someone across the room can still smell it or can smell it. Why do you guys think that is?
um because like when you open a perfume a bottle,
Mm-hmm.
it spreads across the room because like there's
Yeah.
um there's like the cap of it is like
Think of it in like
probably
in terms of like the states of matter.
gas.
Yeah. The reason, you're right. The reason why it spreads, or the reason why you can smell it is because it spreads, because
Oh,
it's a gas.
okay.
Oh, I realized I didn't really talk about particle movement, but another reason why perfume spreads is because its particles move very fast and they spread far apart, like you said. So yes. Um, these are all pictures of what the particles inside the three different states of matter, what they would look like. Do you guys have any guesses as to which ones go with which states of matter? Like which one do you guys think is solid or represents solids?
I think the tightly packed one is solid.
Yes, that is correct. What do you guys think the next one is?
Liquid?
Yes. And then the last one, you guys have to guess. We
Yes.
know that it'll be a
Mhm.
gas. Good job, good job. As you can see, this the picture of the gas provides more explanation as to why it spreads. I know here has a box, but in most cases in real life, the gas around us doesn't have a container, and so it's free to spread. Moving on, matter is made of atoms. We talked about atoms a little bit in our last lesson, but I didn't give you guys a full explanation. But the point is that all matter is made of atoms. They're the smallest part of a substance that cannot be broken down chemically. I know that's a pretty wordy definition, but in simpler terms, they're just the little building blocks of everything around us. I have a little diagram right here, and atoms have a nucleus, which is in the center, which is made up of protons and neutrons, as we can see. And then electrons orbit the nucleus. They move around it. So the different parts of an atom are listed here. First, we have the protons, which comprise the nucleus. They have a positive charge, and like I said, they're located in the nucleus. Next, we have neutrons, which make up the nucleus along with the protons, and they have a neutral charge. After that, we have the electrons, which have a negative charge, and they orbit the nucleus and move around it. So we've been talking about matter, how everything's made up of it, how it's everything around us. But we have a question: can matter change? What do you guys think about that?
I think it can.
Yes, that is correct. There are two different types of changes in matter. There's a physical change, and then there's a chemical change. A physical change is whenever something changes in form or appearance, but it's the same substance, which the definitions might sound a little confusing, but I'll give some examples later. And then a chemical change is whenever a new substance is created and it has different properties than it did before. So some examples of a physical change would be ice melting, cutting paper, water boiling. All of these things change the appearance of the substance, but the properties are still the same. And more importantly, physical changes are reversible, which just means that we can undo them. And then with a chemical change, it comes along with some clues. Um, Evidence of the chemical change would be things like it changing color. Maybe it produces gas, which means that it'll start to bubble. Maybe it'll produce some heat or light. Some examples of this are baking a cake, metal rusting, the brown stuff that gets on metal, and burning wood. So we're just gonna play a little game, which you guys will just guess on whether I'll show you guys like a scenario, and then you can tell me whether it's a physical or a chemical change. And you guys can let me know if you need me to go back to any of the definitions just or something like that. Okay, we have water melting, or ice rather, but you know. Do you,
Liquid?
do you guys think it's a physical change or a chemical change? If you think about it, one of the things about physical changes is that we can undo them, right? It's reversible. And so let's say you have an ice cube and it melts. Can't you just put it back in the freezer and then it'll be frozen again?
Yes.
Okay.
No.
So does that mean that it's a physical change or a chemical change?
Physical change.
Yes.
A physical.
And what if we break a pencil? Would that be a physical or chemical?
Chemical change?
Can't we just put the pencil back together?
No.
We can. It's a physical change.
Oh.
Thinking about it like this, whenever we break a pencil, right? Are we actually changing like what the pencil is made out of? No. And we can put it back together, which just means that it's something that we can undo, which is a clue that it's a physical change. Another example of this would be like cutting paper. If I asked you guys, if I cut a piece of paper with a piece of scissors, or with some scissors, would that be a physical change or a chemical change?
A
It's okay. It'll be a physical change. I'll explain it. It'll make, I guess, a bit more sense later. But yes, the breaking pencil is a physical change. What if we burn wood? Would that be physical or chemical?
Chemical change?
Yes. Can you tell me why it's a chemical
a
change?
chemical change.
Does anyone know why it's a chemical change?
Maybe because like the the chemical, like I think because like it involves the chemical reaction or something.
That's right. That's right. But for yeah, you're correct. What you're saying is right. It does change the composition of the wood, and I guess another way to think of the question I'm asking, is it a physical change? Is it a chemical change? Is if I burn the wood, can I unburn it? Can I undo that?
No.
It's the thing with the pencil. If I break it, can I put it back together? If I cut a piece of paper, can I put that back together? Going back to the beginning, if I melt an ice cube, right? Can't I just put it back in the freezer and it'll become an ice cube again? Things like that. And then what if we dissolve salts in water? We put some salt in water and then we stir it and now it's salt water. Would that be a physical change or a chemical change?
Maybe it's a physical change.
Yes, yes, yes. This is more of a challenging question that I'm gonna ask. But do you have any idea how we could undo dissolving salt in water? It's okay if you don't. I just want to see if you guys have any guesses.
I think like how to like undo is to keep stirring it, like mix the two, like the salt and the water together. And
I see where you're going. I see where you're going. But would that separate the salt and the water? Because what we're saying, right? We're saying that okay, we put salt into water and we stir it. Now it's salt water, but it's a physical change. We can still undo it. So, are there any ways that you can think of that we can separate the salt and the water after we've dissolved it? I'll give you guys a bit of a hint. Oh, yeah. You guys don't have to raise your hand. You can just say it out loud.
Um, so I think that how you can do it is by like taking like one of those like the things I don't know what they are called, but
Maybe a
they're
strainer?
like, I think, yeah.
Okay. Okay. I see what you're saying. I see what you're saying. Thank you guys' guesses. I like you guys' guesses. Problem with using a strainer is that since the salt is dissolved in the water, it'll go with the water, whatever, and it'll pass through the strainer. But I like you guys' guesses. If we did want to separate this, then we could do that by boiling the water. So I'll just go back to my table of like the states. So if we have salt and water, right? Which one of these states would that be if we dissolve the salt in the water?
It would be liquid
Yes.
and solid, or
It, we would just say that it's a liquid because the solid, which is the salt, would be dissolving into the liquid.
uh okay.
And so after we have it in a liquid, if we wanted to separate the salt, then how we could do that is by boiling the water. Because whenever we boil the water, the boiling point, which is just the temperature at which a substance boils, of water is low in comparison to the boiling point of salt. So if we were to boil water, then all of the water would evaporate and turn into a gas. And then we would just be left with the solid salt. Do you guys get that?
Yes.
Okay. Okay. Okay, what about baking cookies? Do you guys think it's physical change or chemical change?
I think it's a a physical change
Why do you think that?
because the the cookies are like because they're like solid, but
I
they're like soft too. So that's why I think it is.
I see what you're saying. I see what you're saying. I I know that I was just talking about states of matter, but whenever we're talking about whether something is a physical or a chemical change, then the states of matter are relevant, but they're not going to be the reason why something is a physical change or why something is a chemical change.
Okay.
But I like that you're connecting everything that I'm saying. I do like that. Um, let me put it like this. Have you ever baked cookies before?
Yes.
Do you know whenever your parents tell you to not eat the cookie dough?
Yes, but I always do.
That's real. It is pretty yummy. But the reason why, did they ever tell you the reason why not to eat it?
So So you could get sick?
Yes, that's because you put things like eggs and unbaked flour in it and stuff. And if eggs are
Oh.
raw, then eating them could make you sick. They could give you something called salmonella. But the point is, how come we can eat the cookies after we bake them, but not before we bake them? That's another way to think about the question too. The properties of the ingredients that you put together in the cookie, they have to change for us to be able to eat them after we bake them, right? So with that, do you guys think that it's a physical change or a chemical change?
A chemical change.
Yes, yes, yes.
And I
Yeah.
know why it's a chemical change. I think I think I know why it's a chemical change, because like you're going to like transform the ingredients with different properties, and then like you add like different like ingredients into the cookies and stuff like that.
Yes, yes, yes. I'm really happy you guys are getting it. Good job, good job. Okay, so now it's time for our little exit ticket questions. So my first one is, what is matter?
Matter is like it matter is like anything that has mass and that takes up space, like the diagram that you showed us, like solid, liquid, and gas, the volume and stuff.
Yes, yes, yes. That is correct. Okay. Second one is, what are the three main states of matter?
Um,
Solid, liquid, and gas.
and then gas.
Yes, yes, yes. Good job, good job. Okay. How do particles move in a solid? Remember the diagram that I showed you of how they looked?
Yeah.
The particles, like solid, and like the particles, how they move in solid is like they take up space and it's like tight.
Yes. And then it's actually my fault. I didn't say this part, but they also vibrate, and as opposed to like being able to move freely. Okay. The next question is, what are the three parts of an atom?
Uh, I think
Um,
like I don't like I know like what the letters start with, but they
okay.
like the first
it's
one like proton, and then
Yes.
I think the second one is like it starts with the N,
Mm-hmm.
and the last one it starts with the like L. It's an electron.
Yes, yes, yes. And the second one is a neutron.
Oh, okay.
And then I know I already showed it here, but you can remember like for proton, you can remember it has a positive charge. They both start with P. For neutron, it has a neutral charge. Both start with that. And then electron has a negative charge. Okay. What is the difference between a physical change and a chemical change?
what is the difference between a physical change and a chemical change? A difference be, between a physical change and a chemical change is that a physical change is a is the change of um a matter that occurs without changing
Remember what I was talking about with the can you like undo it? Can you not undo it?
yeah.
Okay. So
Uh,
okay. You can talk.
Okay. So the difference between a physical change and a chemical change is like a physical change, it doesn't change, and a chemical change, it's like it forms into
Yeah.
different things with different chemical properties.
Yes, yes, yes. That is correct. Um physical changes don't make new substances and chemical changes do. Another difference that I didn't put on here is that chemical changes, for the most part, are permanent, but physical changes are not. Um, okay. And then I call this homework, but to be honest, you guys can just answer it now. I was just going to say, so imagine you have a hot pan, right? And you put an ice cube on it. And then the ice cube, it starts to melt, has some water at the bottom. And then the water that forms starts to turn into steam. What three states of matter are shown in this scenario?
First is um solid and
What's a solid?
and liquid and gas.
Yes. Now, can you tell me like which parts out of the ice cube, the water, and the steam, which is which? Like which one's a solid, which one's a liquid, which one's a gas?
The okay. The solid is the ice cube,
Mm-hmm.
and uh the liquid is the water that's coming out of the ice cube. Then
Mm-hmm.
for the gas is like the steam.
Yes.
And also the pan is solid.
Mm-hmm. Yay. Good job, good job. Okay. That's it for
Wait,
today's
wait,
lesson. Well,